Hi, I'm Lai Thach. I'm an instructor at AJAC, and today we're going to go over the inch micrometer. Today we're going to go over the components of a micrometer. We're going to talk about how to read a micrometer, and we're going to measure a part. The first component we have on a micrometer is the frame. Now, these are outside diameter micrometers. This one measures 0 to 1. This one's 1 to 2, and this one's 2 to 3. The next component we have is the spindle. This is the part of the micrometer that goes in and out for us to take our measurements. And the next component, we call this the outer sleeve or the barrel. This is what, making rotations on them is what moves the spindles in and out of the frame. So diving a little closer, we have the hard stop over here. This is called the anvil. And the inside sleeve here is called the barrel. And the outer sleeve we call the thimble, the part that spins. Going a little further out, we have the ratchet stop. The ratchet stop keeps us from turning too tight onto our part. And we have our spindle lock up in the front. Let's get into reading the inch micrometer. The first scale you should be looking at is called the barrel scale. These numbers here represents 100 thou, 100, 200, 300. Each of the ticks in between the numbers are 25 thou each. So it goes 25, 50, 75 thou, 100 thou. The second focal point should be your thimble scale. Your thimble scale is graduated between 0 to 25 thou. One full rotation of the thimble moves the thimble one tick on the barrel. And if needed, if you are in between thousandths of an inch, you can turn the micrometer around and read the vernier scale. Let's read this number we have on the micrometer here. Let's start with the first step, would be the barrel scale. We see we're at past the 500 mark. One tick, that's 25. Next tick, that's 50. I highly suggest writing that number down, especially when you're first starting out. Our first number is going to be 550 thou. The next step would be to look at the thimble. Lining up the line from the barrel, we see that it's in between 10 and 11 on the thimble. Pick the lower number 10. We're going to add that to our original number, which gives us 560 thou. Notice that we're in between 10 and 11. This measurement is bigger than 560. This is when we do the third step, looking at the vernier. Turning the mic up, and we can see the vernier scale up here. We're going to try to find the line that best lines up on the vernier and the thimble, which happens to be this one right here. Looking at it, it says that's 5. That's 5/10 of an inch. We just take that 5/10 and just tack it on to the end of our number, 560 thou and 5/10. We're going to measure the width of this part here. Open your mic so you can slide right over it. Run this down till we get close. Once we're close, use the ratchet stop in the back to run it down till you hear a couple clicks. Now we can lock our spindle and slide the part right off. Reading the mic from our measurement we just took, we see a 3, so we know we're at least 300. We're past that first tick and the second tick, so that our first number is going to be 350. Reading our thimble scale, we see we're past the 1, in between 1 and 2 on the thimble. We're going to go with a lower number and choose 1 thou, which gives us 351. Since we're in between 1 and 2, we know we have a 10th measurement. We're going to roll this up to the top so we can see our vernier. Find the line that best lines up on our thimble and the vernier.
The vernier scale on a micrometer is most accurate when viewed at a 90-degree angle to the surface. A misread due to viewing the lines at the wrong angle is known as a parallax error. Parallax error is the apparent shift in the position of an object when viewed from different angles, leading to inaccurate readings. especially when the observer's eye is not perpendicular to the measurement scale.
In this case, to me, it looks right around 5/10. And we just tack the 10th to the end of our number there. Gives us 351 thou and 5/10.
To properly hold a micrometer, grasp the frame with your little or ring finger wrapped around it, resting the frame against your palm. Use your thumb and index finger to turn the thimble and spindle to open and close the jaws, while your other hand holds the object being measured. Always use the ratchet or friction thimble for consistent pressure and to prevent over-tightening for accurate readings.
A micrometer is one of the most common measuring tools for precision measuring that you'll find in advanced manufacturing. You guys are probably wondering why you'd use a micrometer over a set of calipers. One thing is, it measured down to 1/10 of a thou. When you're working with tight tolerances, whether it's a couple tenths or a couple thou, you always want to use a set of micrometers instead of a set of calipers. A tip I have for you guys is when you're first starting out, have some scratch paper, a notebook, write your numbers down so that you can do the math out. To wrap this up, we went over the different components on our micrometer. We learned how to read the different scales on a micrometer. We also went over why you'd want to use a micrometer over a set of calipers. Again, go ahead and practice the steps, the barrel scale, the thimble scale, and if needed, the vernier scale, and always write your numbers down.